Hello students, welcome to this session where I'm going to discuss JEE Main Test 57. Yesterday I was about to make the solution, but somehow I recorded the whole paper and then realized that recording is not on, so I was not in the mood to re-record it again. So sorry for that, but I will try to have this series continued. Now today's paper is a regular JEE Main paper. I regarded 5 as tough, 9 as easy, and 11 as medium. So it's a regular paper. Average student should push for 60 or plus, and for good students there should be 80 plus. There are many questions of JEE Advanced as it is asked in the integer one in this paper. So let's see what is in the paper. Let's start the paper. First of all, we start with the question number 1. It says a horizontal disk is rotating with angular velocity omega about a vertical axis passing through its center. A ball is placed at the center of groove and pushed slightly. The velocity of the ball when it comes out of the groove. Now this is a difficult question. Here you need to first find out the speed of this what we say is ball in frame of groove, and then the velocity of groove will be added. So what we will have, this velocity of ball would be velocity of ball with respect to the disk plus velocity of the disk. That is how we are going to do. So first of all, why it moves with respect to the disk? Because of, let's say, when we go into the frame of the disk, let's say, let me draw it like this. Let's say it is somewhere here. Let's say it is slightly displaced by some distance x. So if I do it in the frame of the disk, the forces acting would be, one is the pseudo force that will act and acts like this. This will act radially outwards, that would be equal to m omega square. Let me call it r. Now there are no other force in the horizontal, uh, or in the horizontal it would be along this normal to this. This normal will be acting from the upper wall, I think, but only force which is along the groove component will be this much. And if I write it, it would be theta. And if this angle is theta, this angle will be theta. So the force along the groove, that is equal to m omega square cos theta. That is what force along groove I can write. Now, so m omega square r cos theta, due to constraint of motion, it can move only here with respect to the disk because we are talking in frame of disk. So this cos theta will come out as, if I do this, this is x by r. So it comes out as m omega square r into x by r, that is equal to m a of the ball with respect to the groove. Let's call it a. So this r and r get cancelled. This m and m also get cancelled. So acceleration, which you generally write it as v dv by dx, that would be equal to omega square x. Omega is fixed, x, so we have got it like this. So v dv is omega square x dx. Now integrate it, limit from 0 to v. This will be the v of ball with respect to the disk only. Remember this thing, x will be from 0 to, not r, it would be 0 to r square minus root 3r by 2 ka whole square under root. So this is r square minus 3r square, that is r by 2. So omega square, this is x square by 2, that will become r by 2 ka whole square divided by 2. This will be v square by 2, 2 and 2 get cancelled. So v would be omega r by 2. So this is the v with respect to the disk. Now this with respect to disk will be like this, and because of this circular one, this would be rotational motion, this would be the velocity of disk. This is velocity of what I say, ball with respect to disk. Now looking at it here, let's say this angle is theta, so this is also theta. So if I draw this, what I have this, I can write this sine of theta is equal to root 3 by 2. That means this theta is 60 degree. It means this angle is 150 degree. So the net velocity I will write as Vd is omega r. So it would be what I say, this would be, let me take the pencil, yes. It would be omega square r square plus omega square by 4 plus 2 omega r by 2 into cos of what I have, 150. Cos of 150 is minus root 3 by 2, I can write. So now what I will have, I'll have this as, take omega r as common from all, it would be 1 plus 1 by 4 minus root 3 by 2. So no option as per me is coming out to be correct. And if I do that, they take their solution. In the solution, they have assumed this angle to be 120, which as per me is not the right thing. It is not 120 for sure. This angle is surely theta is 60 degree. Yes, theta is coming out to be 60 degree. So they have taken it to be wrong as per me, or I am wrong. Let me check. This is the normal, this is 90 degree. Definitely these are same angle, so I don't agree with the solution, so there's some issue in it. Now move ahead. Question number 2. A particle starts from rest and traverses a distance 2x with uniform acceleration and moves uniformly over a further 4x, and finally comes to rest after moving a further 6x under uniform retardation. Okay, assuming entire motion to be rectilinear, the ratio of average speed to the maximum speed. So this question we generally do by VT curve. We remember VT curve. So it starts from rest, accelerates, then moves with constant velocity, and then retards like this, and it comes like this. So this is the complete journey that I have drawn. Now this area is 2x, this area is 4x, and this area is 6x. Okay, so the ratio of average speed over the journey to the maximum speed on its way is, so first of all, because it is 2x, it is 6x, and the height of both the triangles is same, so I can say if this time is t naught, this is surely going to be 3t naught. And plus from the logically what I can say, in this t naught time, this half in this is equal to 2x, so definitely this will also be 2 t naught because it is double the area, so that becomes 4x. And let's say what I have this as Vmax. So going by this analogy, what is the total displacement? The total displacement that we have is 6x 4x 2, that is 12x total displacement, and total time we have is 5t naught. So the average speed that we can find out is 12x by 5t naught, that I can write 12x by 5t naught. And what about the maximum speed? The maximum speed I can write from here, this Vmax into t naught. T naught into Vmax is 4x, so Vmax is equal to 4x by t naught. So what you need to know, Vmax upon V average, that is 4 upon 12 into 5, that is 20 by 12, that comes out as 20 by 12 is 5 by 3. So average to max you are asked, so that would be 3 is to 5, so not a tough one, you can do this. It's a motion in 1D problem. Next, galvanometer has a resistance 50 converted into an ammeter by connecting a shunt of value 1, okay, in parallel to the galvanometer. If full scale deflection is 10 milliampere, then the maximum current that can be measured, okay, the full. So now what will be the maximum current now? So first of all, we know shunt is equal to G upon N minus 1, that is what we remember. So 1 is 50 upon N minus 1, so N minus 1 is equal to 50, so N becomes 51 times. So it is 51 times, 51 times means 510 milliampere. That's an easy one for you. That's a regular question on this particular concept. Next, the current through an inductor of impedance 10 ohm, remember, lags behind the voltage by a phase of 60 degrees. So what we can say, if it is XL and R, 10 phi is XL by R, that is equal to 60 degree, 1060 is root 3. So XL is root 3R, and what we have, R square plus XL square, that is 3R square, and the root is given as 10. So what we have, 2R is equal to 10, or R is equal to 5 ohm, and XL is equal to 5 root 3 ohms. That is what I can make from this data. Now the inductor is connected to a 5 ohm resistance in series, then the net impedance. So now what is the net impedance, net resistance? It's 10 square plus 5 root 3 whole square, and a root, what will have, 100 plus 75, so root of 175, so 13 point something should be the answer. So it's 13.2 ohms. Go for option C, that's the best one that we can go for. Next one, the fifth question. A point charge is situated at distance d from one end of a non-conducting rod of length L having uniform charge q. Then magnitude of the electric force. This is a standard question for you. Just take the elements, go from distance x and take as a small element dx. I'll say the charge dq on it would be equal to q by L into dx. Now the force between them, let's call it df, that would be equals to k dq into q upon x square. So writing this k q, this was small q, sorry, this is small q, okay, dq, sorry, I wrote it right, dq into q. So dq was q by L into dx, and what we have, this x square. So complete forces by integration, k q q L common, dx by x square, going the limit d to d plus L, and this would be minus 1 by x integration, 1 by x square is minus 1 by x, minus 1 upon d plus L, minus minus becomes plus 1 by d. So what we will have, L and L will get cancelled, k q q d upon d plus L. So it's a regular question for you, and going by the option, what I can see, this is the D option, that is the most appropriate one. Next one. Three infinite long thin wires, each carrying current I in the same plane, are in the XY plane in a gravity free region. Okay. The central wire is along the Y while the other are at plus minus D. Central wire is displaced along Z axis by a small amount released. It executes SHM. If the linear density is lambda, find the frequency of the oscillation. Now, since displaced along Z axis, we should be very careful while drawing the figure. So, let's say I draw this XY plane to be like this. Let's say this is the XY plane I take like this. This is the XY plane I take, and this would be, let's say, the Z axis. So X axis, Y axis, and now this would pointing would be the Z axis, something like that. So now the three wires were, one is along the Y axis, so one wire is like this, and one wire at x equal to plus d, and one is x equal to minus d. So if I take that view, it would be better. This is minus d1, this is plus d1, and this is the 0 1, and let it be the Z axis now. Okay, so it would be the good figure. Now it is slightly displaced like this. Let's say it is slightly displaced by a distance small z. Now, because they are carrying in same direction, it would be attraction from this wire. It would be attraction from this wire, and symmetry says both attraction will be same. Let's say F naught and F naught. So net force you can directly make out would be, net force I can write minus minus because it is opposite to the displacement, minus 2 F naught sine theta. Now what is the value of F naught? The value of F naught would be what I write, mu naught I1 I2, that is mu naught I square upon 2 pi d. And what would be d? So it would be, if I take that under root a thing also, d square plus z square, it is approximately going to be d thing. So mu naught I square by 2 pi d I can directly write, that is the force per unit length. Okay, so that is F by L. I should write it as now, because this is F by L I am writing, into sine theta. Sine theta you can directly make it out. Sine theta is z. You can again write it as z by d, because the result will be not much. D square plus z square can be written as d. So it is coming out to be proportional to z. That is what we were saying. And F by L, that is equal to ma by L I can write. So what we have, acceleration would be equal to m by L, you know, is equal to lambda. So that would be equals to minus 2 lambda mu naught I square upon 2 pi d square into z. So A is equal to omega square minus omega square z. So I can make out omega value. If I do this, 2 get cancelled, omega comes out to be I times what I have, I times, I can write it as I upon, and this is I will be common, and it would be under root of mu naught upon pi d. I by d is common, it is mu naught by pi, and there should be lambda also. So what we have now, time period is 2 pi by omega, that is 2 pi upon omega. If I'll do this with this will become, you need to find out frequency, sorry, not the time period. So frequency is omega by 2 pi, so 2 pi divide, so f would be omega by 2 pi I upon 2 pi d under root mu naught lambda by pi. So I think which option is coming? Which option is coming? The option coming for me is m by L lambda. Okay, I've written it wrong. It should be here. This lambda will be here. So uh, better do it like this. We are good that no such option, that option was also given. We would have done wrongly. This is option A, not B. So be careful. Don't do such mistakes. Next, seventh one. Two cars A and B are moving at speed of 15 and 5 and acceleration 1 and 6, then the minimum separation between them is, okay, so we have to find for the minimum separation. So we know minimum separation comes when V relative will be 0. So when will be the V relative 0? I can make it out. Let's say 15 plus 1 into t would be equal to 5 plus 6t. So can I directly write now? Yes, 10 is equal to 5t. So at t equal to 2 seconds. So at t equal to 2 seconds, it would be the minimum separation. Now you can do by relative or you can do by individual. Let's say I do by individual. What is the displacement of b by t then? That is 5 into t plus half into 6 into 2 square. That comes out as 10. 10 plus what we have, 12, 22 meters it has moved, and b, if I think will move by 15 into 2 plus what I have, half into 1 into 2 square. So it would be 30 plus 2, 32 meters. So gap reduces by 10 meters. So the minimum gap is going to be 10 meters. So go for option B. Okay, next. The eighth one, two blocks of masses m1, m2 being connected by light spring of constant k are driven by forces f1, f2 on a smooth plane. The blocks move with same acceleration a naught. The value of a naught is, let me look at the figure. So both are moving at same, so that is would be ACM. So I can directly treating them as system. I can say spring force is internal. So net force would be F1 minus F2 forward. That would be equal to total mass m1 plus m2 times a naught. So a naught is f1 minus f2 upon m1 plus m2. That's an easy one for you. You can go for option A. Next one. To determine the half-life of a radioactive element, a student plots a graph ln dn by ln dt versus t. Find here dn by dt is the rate of decay. The number of radioactive nuclei of the element decreases by a factor of p after 4.16. Here the value of p is, this is the same question that has been asked in, I think, JEE Advanced is an integer type question, I remember. So let me do this. What we know dn by dt, we have the formula that is equals to lambda n, or you can write it lambda n naught e to the power minus lambda t. Now if I take, what you have to take, ln of this thing. So ln of this whole thing dn by dt, if I do and take in the mod, what I will have, this is ln of this, so it would be ln of a into b, to ln plus I'll do, so that would become minus lambda t. You can do this ln a plus ln b, and that ln b is minus lambda t. So this is what we have. So this is the curve we are having. So it is y equal to, I can relate it as c minus mx. Okay, slope is negative, so that we have to find out what the decreases by a factor of p after 4.16 years. Okay, so what is this 4.16 years? First of all, I need to check. So just looking at first the slope m lambda. So looking at this slope, what I can get, these are the 2 points I'm marked with. So if I mark it, the slope's value is, this is 1 by 2 and years. So what I have, lambda is equals to 1 by 2 year inverse, I should write. This is the value of lambda. So what is the t half now? First find out t half. T half you know is ln2 by lambda. ln2 is approximately 0.693. If I divide it by half, what I get, 1.386 years. And if you do this 4.16, if I multiply it by 3, what I get, 18, 1, 3 8s are 24, 5, 3 3s are 9, 11, and 1, 4.15, it is almost 4.16, so you can directly say it is approximately 3t half. So what it becomes 1/8. So the value of the factor becomes, what it is given, decreased by a factor of p. So the factor of p is equal to 8. We can go for option A. You can do it like that. Okay, so just remember this. You have to first find this t half, and it's approximately, it's almost three half lives, you can directly say. Now a cylindrical piston of mass m slides horizontally smoothly inside a long cylinder closed at one end. Enclosing a certain mass is kept with its axis horizontal. The piston is disturbed from its equilibrium. It oscillates SHM. The period of oscillation will be, okay, so initially it is at balance and is placed horizontally. Okay, the axis of the cylinder, that means it is in a horizontal plane. M slides smoothly inside a long cylinder. Okay, now if it is slightly displaced, because it's assumed to be an isothermal process, let's say I push it by distance x. If I push it by distance x, the change in volume would be dv would be equal to minus a dx. And because it is isothermal, I know dp by dv is equal to minus p by v. So the change in pressure would be positive, and that would be equal to dv. dv is what? ADX into P by V. That is what I can write. So the additional force created is dP into A. So that is force is dP into A, and that force would be in a, let's say, because it has increased, it would be opposite to the displacement. So I can write it as minus dP into A. So dP into A, if I do, so dP will become as P by V ADX into A. I can write again. Okay, so again I can write it as A, and this volume I can write it as AH. So A will get cancelled. This would be PA upon H into dx with negative sign. So it definitely it executes SHM, and omega I get would be equal to root PA by MH. So time period is 2 pi under root of MH by PA. So if I look at the option, which one is satisfying? The option A is satisfying, so go for it. Next. Now the next one, 11th. The graph shows the variation of current with the applied voltage in photoelectric effect experiment for 3 different beams of light falling on identical metal surfaces. Then which of the following is correct? So we know this saturation current depends on intensity. That means A and B have same intensity. And this is the stopping potential is same for B and C. That means not so, so sorry, that what we can write it is the yes, a stopping potential is same. That means k max is same, or you can say the phi is going to be same for B and C. So frequency, sorry, frequency is going to remain the same because the metal surface is same. So B and C will receiving the same frequency, and A and B having the same intensity. Intensity of A equal to intensity of B greater than intensity of C. So looking at these options, this is A1 is the most appropriate. So this was A. Next goes on. A sniper fires a rifle bullet into a gasoline tank, making a hole 53 meters below the surface. So let's say this is the, let me take some other color. Yeah, this is like this. 53 meters below the top surface. It was sealed, so it was packed, and 53 meters here we have this. The stored gasoline has density. This is the velocity which the gasoline begins to shoot out. So gasoline begins to shoot out. If I need to remember, I just need to apply the Bernoulli, because here the speed is going to be very less. Let's compare to B and A, or something to pressure at B would be that 3.10 atm plus rho gh plus speed is, let's say, almost negligible. That would be equal to P naught plus half rho V square. So what we will now have, P naught is 1 atm, so this is 2.1 atm converted into the standard result. So 2.1 into 10 to the power 5 approx you can do, 1.01 you can do, or 10 to the power 5 for simple calculation. I'm taking gasoline density 660 into 10 into 53, that multiplied by 2 whole thing divided by density is what, 660, that will under root will give me the B. Okay, so doing this, what we get, 1 upon 330 I can do there, and if I do 10 to the power 5, this is 10 to the power 3 4, so it becomes 2.1 plus 5.3 into 0.66 I can write, that would be 10 to the power 5. Okay, so now what we have, so doing this, what we'll get, 1 upon 330, and if I do this, 53, 66 3s are 198, 330 plus 19 would be 349, 349 and 3498, so 3.498, 2.1 plus this into 10 to the power 5. So if I do this 1000, this would be almost 3 times, so 300 into what we have, 300 into 5 point something, so it is 1500, 1600 plus. So we could directly go for these option, 41 meter per second approximately this will come. I have done many approximated calculations, so you can do the complete results. Now this was the fluids based question. Now the microscope. In a compound microscope, the objective lens and eyepiece have focal length 0.95 and 5 respectively, and are kept at a distance of 20 centimeters, that is you are given. If the last image is formed at a distance 25 centimeter, that means it is in the near point adjustment that you are given. So magnification power in the near point adjustment you need to find out. So I have the formula that magnification power would be minus V naught by U naught into 1 plus D by FE. That is the result that I use. So minus VO by U into 1 plus D by FE, D you know, FE you know. So we need to find out VO and UO. Okay. So what we have, they are kept at a distance 20 if the last image is formed at a distance of 25. So simply for what I have, this is the objective for the compound microscope, this is objective, and let's say this is the eyepiece that I generally have. So because last image is formed at 25 centimeter, so what I can do, I can write it for this, because it is, you know, the image formed is virtual, so it is not formed 25 here, it would be 25 here, something like this. This would be the final image like this. This distance is 20. So writing this equation, what we have, 1 upon 25, 1 upon V, that is minus 1 upon 25, minus 1 upon U, that would be equal to 1 by FE, FE is 5, so 1 by U for eyepiece I should write would be equal to minus 1 by 25 minus 1 by 5, LCM is 25 minus 6, so UE comes out as minus 25 by 6 centimeters. Okay, so what we have now, here the length that I'll be having is 25 by 6 from here, so this distance become 20 minus 25 by 6, that is 120 minus 25, that would be 95 by 6. So applying here, 1 upon VO, that is 1 upon 95 by 6, minus 1 upon UO, that is equal to 1 upon FA, that is 1 upon 0.95. So 1 upon UO is 6 upon 95, and this would be 100 by 95 I can write. So UO would be 95 by 94 minus I can write. So the VO by UO, if I do, VO was what was VO? VO was what I write, 95 by 6. So that was 95 by 6. I'm just checking the magnitude because I know this UO we written as 95 by 94 into 1 plus 25 by 5. So this is 6 cancelled, so this would be 94. Go for option A. So use this and use your basic lens combination results to arrive to the final answer. Next one. A cyclist riding the bicycle at some speed takes a turn of radius this without skidding. What is the inclination to the vertical? Okay, so he takes the turn without skidding, and here what I mean is that there should be no friction. So simply it it bends itself for you. It will be like it is doing the banking something. So the diagram will be the similar, and this would be the normal one component balancing mg and one providing the necessary centripetal force. So let's say this angle is theta. So what I can write, n cos theta is equal to mg, and sin theta provides the necessary centripetal force mv square by r. So tan theta would be, directly you can write v square by rg, that is the famous relation you know. So 14 root 3 whole square divided by 20 root 3 into 10. What do you have? 14 into 14 into 3, that is 20 root 3 into 10. So this becomes root 3 here there. And what we now have, 14 into 14 is 196. So better G take as 9.8. It is also given. I just checked the data and I realized it should be 9.8. So because of 9.8 thing, this become 196. I know. So this is 9.8. So this is also 196 and root 3. So tan theta is root 3 means 60 degree. Go for option. So next question, let's take question number 15. A germanium specimen is doped with aluminium. Aluminium means you can say it is a p-type. The concentration of acceptor atom is given 10 to the power 21. Given that the intrinsic concentration Ni is 10 to the power 19, the concentration of electrons. So what we have, because it is p-type, Nh will approximately be Na, so Ne will become Ni square upon Na. So what we have, Ni square is 10 to the power 38, this becomes 10 to the power 21, so it becomes 10 to the power 17 per meter cube. So go for option A, that's a regular question. Next one, a monogas undergoes a process in which PV are related. This is a polytropic one. If you have not studied, please check my physics in 5 minutes revision series. I have done this in 5 minutes. You will be able to do this very well. So here what we have, PV to the power x is constant, and we know C is CV plus R upon 1 minus x. So here the x is minus 3, CV is mono is 3R by 2, x is minus 3, so 1 minus minus 3 becomes 4. So what we have 7R by 4. So easy one for you if you know that polytropic one. If you don't know, please watch that video. 7R by 4. Next one, 17. Two resistances are measured in ohm like this. They are connected in parallel, the percentage error. So when they are connected in parallel, for a small changes, what we can write, delta Rp by Rp square will be equal to delta R1 by R1 square. Using that 1 by Rp is 1 by R1 plus 1 by R2. So we can write it like this. So what we have now, first of all, as per the 3 and 6, the parallel value would be 2. So delta Rp upon what I can write, Rp square, or upon Rp I can write it as Rp into delta R1 by R1 square plus delta R2 by R2 square. That would be beneficial for us. This will be 2 delta R1, because it is 1%, this is 3 1%, that is 0.03 by 9 plus 0.12 by what we'll have by 36. So what we get now, 0.06 by 9, 0.06 by 9 plus this becomes 0.24 by 36. So if I have to do it in percent, multiply by 100, so it becomes 6 by 9, that is 2 by 3, plus this becomes 24 by 36, that is 2 by 3. In percentage, that becomes 4 by 3%, so I can go for 1.33%. So it's in regular one if you know this result. Next question number 18, go for it. Unpolarized falls on two polarizing sheets placed on one top of the another. What must be the angle between them if the intensity of final transmitted light is 1/3 the maximum intensity of the first? Okay, so first you know is I naught by 3, and you need I naught by 2 cos square theta to be 1 by 3 of I naught by 2. That is what you need. So what you need, cos square theta is 1 by 3. So cos theta is 1 by root 3. So it's an easy one for you. So this option C, cos inverse 1 by root 3. Just read it carefully and do. Length of a sonometer wire tuned to a frequency of 250 Hz is this. The frequency of tuning fork with which the vibrating auto will be in tune when the length is made 0.4. So we know frequency is inverse to L. So if you have made the length 2/3, the frequency becomes 3 by 2. 3 by 2 means 375 Hz. Go for option B. It's again an easy one. Next, a particle of mass m 1 kg dropped into a height 40 cm on light horizontal platform fixed to one end of a spring fixed to a base. The particle collides and sticks to it. Okay, as a result, the spring is compressed by amount 10 centimeter. What is the force constant of the spring unit? Because the platform is light, we don't take any energy loss due to that sticking. And simply writing this, let's say it is compressed by 10 centimeter. So writing between this and this energy equation, energy conservation, taking system as the complete plus earth. So what we'll have, the gain in spring energy half kx square is equal to loss in the potential energy, which is mgh plus x, because initial speed is 0, final speed is 0. So simply this equation is what we have. So the value of k comes out as mg h plus x multiplied by 2 divided by x square. What do you have? 2 into 1 into 10, h plus x 0.4, 0.5. and this is zero point 0.1 square. So what you have now, this becomes 100, goes over 20, so this is 2000 into 0.5, so it comes out to be 1000 Newton per meter. Go for option C. This is directly you can do using your energy analysis. Next one. So now the subjective ones first. Z equal to 92 emits in the following sequence. What is the atomic number? So atomic number, you know, is changed only by so it is changed alpha and beta dono, because the mass number changes by alpha only. Okay, so 1 2 3 4 5 6 and 7 alpha, 8 alpha. 8 alpha means it decreases by 16. 1 2 3 4. 4 beta means it increases by 4. Beta plus decreases, so decreases by 2. So decrease of 18, increase of 14, so total decrease will be 14. So total decrease will be 14, no, sorry, not total decrease will be, yes, 14. 14 means 92 minus 14, that comes out to be 78. So it's a good one, beta plus. First time I'm seeing such questions. Generally you had beta minus only. Next one, body of mass m moving with velocity v collides head on elastically with 2m mass which is initially at rest. The ratio of kinetic energy of mass m before and after the collision. Okay, so after the collision, what would be its speed? Directly I can say its speed v1 would be equal to m1 minus m2, which is m minus 2 upon m plus 2m into initial speed, that was v. So it becomes minus v by 3. Direct formula I have applied. So speed has become 1/3, so kinetic energy will become 1 by 9, or before and after, so it would be 9:1. So 9 would be the answer. Now not 9:1, you will substitute only as 9. Next. 23rd. Large sphere of mass m is fixed at one position and two identical particles of mass small m are kept on a line passing through the center. The point masses are connected by a rigid massless rod of length L, and this assembly is free to move along the line connecting them. All three masses interact only through mutual attraction. When the point mass nearer to m is at a distance 3L from m, the tension in the rod is 0 for m equals to this the value of K. This is again a straight question, JEE advanced, previous question taken as it is. Okay, so the tension in the rod becomes 0. So why this the tension in the rod will become 0? Simply I will say both will be accelerating. It cannot happen but both will remain rest, because it will only having attraction forces towards left, so it cannot be at rest. So both acceleration will be same and tension becomes 0. So for this one, this attraction is gmm by r square. R square means 9l square minus attraction of that one, that is gm square by l square, that would be equal to ma. And for this is gmm by 9 by 3 plus 4l, that is 16l square, plus gm square by l square equals to ma. So equating both the things, that what would we get? We get a gmm taking common 1 by 19 minus 1 by 9 minus 1 by 16 is equal to 2 gm square by l square if you equate it. So gm. Now what we have, L square was also there, L square cancel kare. What we have, m into 7 upon 144 equals to 2, so 2m, so small m is equal to what I can write, 14m upon 1 288. If I have to, no, yes, 7m, not 2 is coming there, no need to do this. This would be 7m upon 288, so the value of K comes out as 7. So this is a question for JEE from JEE advanced lifted. Now next one, two rectangular blocks A and B of different metals have the same length area, lengths aligned and the cross section in contact. Temperature at one end is 100, at B is 0. Ratio of conductivity is 1:3. What will be the temperature of the junction? So again, such questions are coming in NEET also. So these are the two, A and B. This is 100, this is 0. Now, the ratio of the thermal conductivity is 1:3. So this is 3R and R I can take, because resistance ratio would be 3:B. So the drop would be a 3/4. 3/4 means 100 by into 3 by 4. So this would be 75 drops. So it would be 25 degree Celsius at the junction. So it is 25. Don't write it 75. 75 is a drop. So answer is 25. Now the last one. Let's see what it is. 2 moles of a mono gas taken through a cyclic process on the PT diagram. The process CA is represented by PT is constant. This is also one of the advanced question lifted. Not exactly, it is a subjective, and if the efficiency of the cycle is this, then what is the value of x? Okay, so what is the efficiency of the cycle? First, A to B. I can say it is an isobaric process. So I can write work done as positive nr delta t. 2 moles r delta t comes out as 300. So this is 600 r. Okay. Now B to C is isothermal, pressure decreasing, so volume increase. So positive work nRT ln V final upon V initial I can write. So nRT ln V final upon V initial, so 2 into R into 600 into ln of P initial upon P final I can write ln 2. So it is 1200 R ln 2. Okay. Now C2A. Now PT is constant. I can rewrite it as T. I can write it as T is PV upon NR constant. So it becomes P square V constant, or it becomes PV to the power half is constant. So as in the polytropic process, what I can write C is CV plus R upon 1 minus X, and work done directly I can write as N R upon 1 minus X into delta T. From the logic I told you in my 5-minute revision series, you can again recap that. So N is 2, 1 minus X, X is half, so that becomes 1 by 2 into delta T is minus 300, so negative work, it would be minus 1200 R. So in the C2A, W is minus 1200 R. So this is the network done. Network done, if I had to calculate, this would be 600. So this is 1200 R ln2 minus 600 R. That would be the result. That is W net. Now to find the efficiency, you have to find the divided by Q net, Q in, sorry, basically. So here the signs of 3 are same. So this is Q out. Q in will be a Q in will be in AB and BC. So what is QAB? QAB is NCP delta T. So 2 into what gas? Mono. 5R by 2 into 300. So you get it as 1500 R. QBC. QBC is the same as work, that is 1200 R ln2, and here it would be negative, so no need. So W divided by Q input, that comes out as 1500 R plus 1200 R ln2. So if I do this, what I will get efficiency as W by Q in. So this 600 R or the 300 R I take as common. So this becomes 4 ln2 minus 2 upon what I have, 5 minus 4 ln2. So this is what the result I have. So this is 4 ln2. So doing that 5 plus, sorry, not minus, it is 5 plus 4 ln2. Now doing this, getting this whole thing above, that would be efficiency would be 1. I need plus 5. So I've added what I have added. I have added plus 7. So I need to plus 7, and that would be minus 7. So that would be 1 minus 9 upon what I have, 5 plus 4 ln2. Okay, is it okay? ln2, because if I do plus 5, and this would be plus 5, and this would be minus 7, sorry, not minus 2, it would be minus 7. Minus 7, okay. So 5 plus 4 ln2, and now if I have to do this 3 times, so that will become 21. So comparing that, it should become 21. So this is the answer. So it's quite a tricky one, but that was the paper for today. Keep sharing the channel. Thank you.